The least common multiple. That's it.
So would that be 30? Not 30,
60?
For the number 2.
On the front side, it would be. You said 60?
Yeah.
So, Jasmine, for the sake of us actually just doing that problem, guys, this is the problem Jasmine's talking about. It's number 2 on page 124. It's 3 over 20 plus, minus 4 over 15. And what Jasmine said is the least common multiple of 20 and 15 is 60, right? So we can rewrite this fraction as the difference of something over 60 and something over 60. Why 60? Because 15 times, what is it? 15 times 4 is 60. So let's multiply both top and bottom by 4. And what is the common, what multiple do we multiply 20 by to get 60? 3. Good. So we would multiply both numerator and denominator by 3. Okay? 3 times 3 is 9. 4 times 4 is 16. And now we can subtract the fractions because why? Yeah. Common denominators. Folks, what's 9 minus 16? Positive or negative?
Oh, wait, hold on. 7.
Positive or negative?
Negative?
Good. If you have 9 apples, but you owe me 16 apples, at the end of the day, you still owe me 7 apples, right? So that's something that y'all could evaluate in your calculators. 9 minus 16 is equal to negative 7, all right? We cannot simplify this fraction anymore because 7 is prime, right? And 60 is coprime with 7. In other words, they don't share any common factors. Okay? All right, let's go to the next page, folks. Page 125. I want to work through 3 problems together as a class, and then I'm going to let you guys go and hopefully work more individually with those of you who need help, okay? So I'm going to try on page 125, problem A. We have A plus B over 4 plus 2A minus B over 5 plus 2A minus B over 5. Make the denominators 20. Yes. Jaren, do 4 and 5 share any common factors? Are they multiples of the same number?
Yeah.
They are both factors of 20, but my question is, do they share any common factors? Do they have any common numbers that multiply to equal either of them? No, right? So they're both coprime, so we can use the algorithm. We're going to multiply across, and then we're going to multiply the denominators, okay? So let's try this. What is 5 times A plus B? What's 5 times A plus B? Well, you know what, let's just write it out. Let's just write it out for now. So we get 5 times A plus B, and then 4 times 2A minus B, okay? Plus, I'm using plus because that's the sign here in the middle, okay? Plus 4 times 2A minus B. And this is going to be all over 4 times 5. What's 4 times 5? 20, good. Yeah, that's it. Now we can do a little bit of simplification. Let's go ahead and distribute, okay? 5 times A and 5 times B. Adam Martinez, what do you think? What's 5 times A? 5A, great. What's 5 times B? Sweet. 5A plus 5B. Over here, Camille, what is 4 times 2A? 4 plus 2 is 6, but 4 times 2A is 8A, great. Positive 8A, and then last but not least, 4 times negative B. What's 4 times negative B? What do y'all think? Commissar, what's your thought? Negative 4b. Awesome. Negative 4b. Again, this is all over 20. Can we combine like terms? Are there any terms that, which ones? 5a and 8a, great. And 5b and minus 4b. Okay, let's go ahead and combine those terms. 5a plus 8a is how many a? 13a, okay. And 5b minus 4b minus b. So if you have 5 bananas, but only 4 bananas, you are left with 1 banana, right? Plus 1b. And for sake of being a mathematician, a lazy mathematician, I'm just going to write b because it's understood that 1 is already there, okay? And this is all over 20, okay? And that is how you simplify number 1, okay? That's 1a. Okay, so that's a really good question. When I'm looking at these coefficients, 13, 1, and 20, I recognize that these are all co-prime numbers. So 1, 13, and 20 don't share any common factors, right? So I'm not going to divide through any common factors. And I also recognize that these variable terms are different. So I can't do any sort of, even if I wanted to factor, there are no factoring techniques that simplify something like this, okay? If this were an a, I could probably factor out an a, right? So if this were 13a plus a, well, that would be 14a, right? But because this is a b, there's really a square term could add to factoring, right? We know how to factor quadratics, so maybe this would be something that could be factored. Maybe if there was a constant term being added, and maybe it was a trinomial, ax squared plus bx plus c, maybe we could factor it. Maybe it would cancel with the 20. Okay? But in this case, it looks pretty simplified to me. In fact, it looks way more simplified than the original problem, right?